Good morning, champs. Today we are going to identify the zero force members in this truss without calculating the support reactions or the remaining member forces. A zero force member is a truss member whose axial force is zero under the current loading condition. This does not necessarily mean that the member is unnecessary. It may help stabilize the structure, and it may carry force under a different loading condition. Before applying the rules to our example, let us review the 3 rules for identifying zero force members. The first rule applies to an unloaded joint where only 2 non-collinear members meet. Because the 2 forces act in different directions, they cannot balance one another. Horizontal and vertical equilibrium can only be satisfied when both member forces are zero. Therefore, both members are zero force members. The second rule applies to a joint with 2 members and an external force. If the external force acts exactly along the direction of one member, that member can balance the external force. The second member acts in another direction and has nothing to balance it. Therefore, the second member must be a zero force member. The third rule applies to an unloaded joint where 3 members meet. If 2 of the members are collinear, the third non-collinear member must be a zero force member. The 2 collinear members act along the same straight line. In the perpendicular direction, only the third member contributes. Equilibrium, therefore, requires its force to be zero. There is one additional strategy that is especially important in today's problem. We must apply the rules repeatedly. After identifying a zero force member, we conceptually remove it and inspect all the joints again. This can reveal additional zero force members that were not visible during the first inspection. Let us now examine the adapted truss. 3 members meet at this joint. Members 2 and 4 lie on the same horizontal straight line. Member 3 is vertical, and no external force acts at the joint. This is exactly the third rule. The 2 horizontal members are collinear, while member 3 is non-collinear. Therefore, member 3 is a zero force member. The axial force in member 3 is 0. Now we conceptually remove member 3 and inspect the truss again. Consider the upper middle joint. Originally, members 1, 3, 5, and 6 met at this joint. Because member 3 has already been identified as a zero force member, it does not contribute to the equilibrium of this joint. We are therefore left with 3 effective members. Members 1 and 6 lie on the same inclined straight line. Member 5 is non-collinear, and no external force acts at the joint. The third rule now applies again. The non-collinear member must carry zero force. Therefore, member 5 is also a zero force member. This explains why member 5 could not be identified immediately. Before removing member 3, 4 members met at the upper joint, so the standard 3-member rule could not be applied directly. Only after recognizing that member 3 carries no force does the second zero force member become visible. The final result is therefore simple. Member 3 is a zero force member, and member 5 is a zero force member. The important lesson is not only to check every joint once. After identifying a zero force member, remove it conceptually and inspect the truss again. Some zero force members can only be recognized step by step,